Hi everyone. Today we're talking about the idea of exponential functions, but actually how do we write them? So we've talked about linear functions and exponential functions. We talked about how to write linear functions. And now today we're talking about how to write exponential functions. So go ahead and follow along with your notes. Remember, exponential functions where they're also called geometric sequences constantly multiply or divide by the same number. So exponential functions take the form of y equals a times b to the x power. Okay, so we know how linear functions are y equals mx plus b. Exponential functions are y equals a times b to the x. Okay, so in this case, a is the y-intercept, meaning where the function crosses the y-axis, and then b is the multiplier. So let's say you had an equation like this. 3 times 2 to the x power. 3 would be the y-intercept, and 2 would be the multiplier, what it's constantly multiplying by every time. Okay? So the y-intercept is where the pattern starts, meaning the value when x equals 0. Okay? The multiplier is the rate of change, meaning the number that is being multiplied or divided. Okay? So go ahead and make sure you write that down, and then let's move on to how we actually do these in an example. Okay, so here's the first example. It says, write an equation for the number of circles in the pattern. Okay, so if we look at this pattern, we'll call this figure 1, figure 2, and figure 3. And we want to leave enough room for a figure 0 because that's really where it starts. Okay, so we'll say 0, 1, 2, 3. So if I look at figure 1, I see 1, 2, 3, 4, 5, 6 circles. And if I look at 2, actually 6 circles, 12 circles. Okay, and then if I look at figure 3, I don't see 12 circles, I see 24 circles. So you might have noticed a pattern while I was doing this, and if you didn't, if you could just look at the numbers, 6, 12, 24, you should notice a multiplier for these. 6 times 2 is 12, and 12 times 2 is 24. So to be able to figure out figure 0, we can divide by 2, and we'll find out that we have 3 circles, which makes sense, because 3 times 2 would be the 6, times 2 would be 12, etc. Okay, so that means we figured out where we started, right, at 3, so that's our y-intercept. It's 3 times, and our multiplier was 2 times 2 to the x power. So that's our equation. Now if you want to check this out on a graph, that'll be helpful for you to understand what it looks like. So 0, 3, that's right here. 1, 6, that's right there. 2, 12, right here. And 3, 24 is off the charts. But you'll notice you see this exponential growth. It's not a straight line. Okay. Now finally has a question that says how many circles would there be in the 7th pattern? Okay, so that means if I kept going here, 4, 5, 6, 7, what would that number be? Now you could just keep multiplying by 2, or you could use this equation. So if you use this equation, y equals 3 times 2 to the x, instead of the x, you can put 7. So y equals 3 times 2 to the 7th power. Now be careful here. You want to make sure to follow order of operations. So you want to do the exponent first and then multiply it by 3. So if I use my handy dandy calculator, I can see that 2 to the 7th power is equal to 128. So that means that I have 3 times 128. Then I'll multiply it by 3, and that gives me 384. Meaning that there will be 384 circles in the 7th pattern. Okay, so that's the first example. Let's do a couple more, and then that'll be it. So here's the second example. It says the following pattern represents the number of bacteria cells in your bloodstream, and this should say before you have taken medicine. With each hour that passes, the number of bacteria says increases. Okay, now it says write an equation for the number of bacteria after x hours. So that means that x is going to be the hours, our independent variable, and that this is going to be bacteria. So if I'm looking at this, I see this is the first hour, this is the second hour, this is the third hour. And I still need to figure out what hour 0 looks like. So I'm going to put in hour 0, 1, 2, 3. So let's start with the ones that I know. Hour 1 has 2 bacteria. Hour 2 has 6 bacteria. Hour 3 has 18 bacteria. You can count those up to make sure that I'm doing this correctly. Now when I look at those numbers, I start to recognize a pattern. 2, 6, and 18. I know that 2 and 6 are related if I multiply 3, and 6 and 18 are related if I multiply 3. So I found my multiplier. Now I just need to divide by 3. So this creates slight issue, but it's okay. I can just put 2 over 3. So I just found my y-intercept, and I just found my multiplier. So I'm going to write my equation. It's y equals 2/3, because that's where I started from, times 3, because that's my multiplier, to the x power. So I just figured out my equation. Let's put it on the graph so we see what it looks like. 2/3 is between 0 and 1. 1 and 2 is right about here. 2, 6 is right here. 3, 18 is right here. So then again, we see this exponential growth here. Okay? Now the final question says, how many bacteria would there be in the 6th pattern, or really 6th hour? Right? So again, you could keep multiplying by 3, 4, 5, 6, or you can use the equation. So let's use the equation. Y equals 2/3 times 3 to the x, but instead of x, I'm now going to put 6. So I'm going to say y equals 2/3 times 3 to the 6th power. So let's go ahead and do this. So again, I want to do my exponent first. 3 to the 6th power. Use my calculator. 3 to the 6th power gives me 729. So that's 2/3 times 729. So now I can put this over 1. So I'll multiply 729 by 2 straight across. So that's 1458 divided by 3. And then let me see what that gives me. 486. So that means that 486 bacteria would be present in the 6th hour. Okay, and let's do the final example. So example 3 says the following pattern represents a field of flowers growing. Each pattern represents their growth after a week. Write an equation for the number of flowers based on the number of x weeks. So this is weeks, and this is flowers. So again, this is week 1, week 2, and week 3. And this is week 0. So I've got 0, 1, 2, 3. Okay, so again, in my first week, I know I have 1 flower. My second week, I have 2 flowers. My third week, I have 4 flowers. Okay, so this isn't adding by the same number, so I know that this is going to be an exponential function because I actually can see that it's multiplying by 2, multiplying by 2. So to figure out where I started from, I'm going to divide by 2, and that's going to give me 1/2. Okay, so let me write my equation because I now have my y-intercept and I have my multiplier. So it's going to be 1y equals, what was my y-intercept? 1/2 times 2, because that's my multiplier, to the x power. So that's my equation right there. Let's go ahead and graph this. 0, 1/2 is right there. 1, 1 is right here. 2, 2 right here. 3, 4 right here. So this one's a little bit more difficult to see, but you do see that it still has that exponential change. Final question says, how many flowers would there be after 7 weeks? So again, this is the situation where I can use my equation. I'll go y equals 1/2 times 2, but instead of x, I'm going to write 7. I follow my order of operations. I'll do 2 to the 7th power. Use my calculator again here. You could do this by hand. Remember, this just means 2 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. Okay, 2 to the 7th power. So that's 1/2 times 128. Multiply that by 1/2 and I get 64. So after 7 weeks, there would be 64 flowers. If you have any questions, please let me know, and I hope you understand this.